questions for 2024 JEE Advance. The question is, find total number of conformers possible for the product of the reaction which involves the addition of bromine across the carbon-carbon double bond of this compound. Now, let us have idea of conformations. Conformations are different orientations obtained by rotating about single bonds. In this case, let us take carbon-carbon single bond. Consequently, each orientation has different energies. And when the conformations and their energy is plotted to have a surface energy diagram, then local minima occupied by the conformations are called conformers. Conformations are well understood by plotting Newman projection from Sahar's projection. In Sahar's projection, let us suppose the carbon-carbon single bond, that is a friend carbon, and in Newman projection this is a friend carbon. In Sahar's projection it is a back carbon. In Newman projection, back carbon is represented by circle. These are the three bonds on the front carbon, and here the three bonds are in a front carbon. These are the three groups A, B, C, and here A, B, C are three groups of the front carbon. Similarly, on back carbon, we have three groups D, E, F, and here also on back carbon D, E, F. This is Sahar's projection, this is Newman projection. Newman projection is better way of studying the conformations. As example, take N-butane, C1, C2, C3 and C4. Study conformations about C2, C3 bond. Now, suppose if it is C2 carbon, this is C3 carbon, this is C1 carbon, this is C4 carbon. Now C2 and C3 carbons, this is C2, C1 carbon. Imagine a plane that contains C2, C3 carbon, C2, C1 carbon. This is C3, C4 carbon. And let us make a plane that contains C2, C3 and C3, C4. The angle between these two planes is called dihedral angle. By changing dihedral angle, you can change the relative positions of the groups on front and back carbon by generating various conformations. Let us see how. That is a front carbon containing methyl, hydrogen and hydrogen, and back carbon has methyl, hydrogen and hydrogen. It is eclipsed conformation. Now when rotate by 60 degree by holding the front carbon tight, then we are going to have a new conformation where the dihedral angle is 60, methyl and methyl groups are far. Now by further rotating 60, we are having CH3 group here and hydrogen here and hydrogen here. And one more 60 degrees. Now we'll bring CH3 from here to here, that is anti. In further 60 degrees, we have new conformation, and for next 60 degrees, you have CH3, CH3, again this kind of interactions. If you plot energy variation of these conformations, we obtain a graph like this, which says that this particular conformation is having higher energy due to more torsional strain and steric interaction, and whereas this conformation where methyl groups are largely separated has a least torsional strain and steric interactions, and having lower energy. And coming to this conformation, here methyl and methyl groups, Gauche interactions will make it less stable when compared with this particular conformation. And these are the local minima in surface energy diagram of conformations drawn about C2C3 bond of N-butane. And these three are called conformers. Now going to our question, what is the product obtained by addition of bromine across carbon-carbon double bond? It is electrophilic addition and stereoselective and specific and anti-addition. Before going to answer the question, let us take a trick. Addition across carbon-carbon single bond, configuration of carbon-carbon single bond, and product in Fischer projection. Suppose if addition is in, let us say positive, anti, let us say negative. If configuration is cis, say it positive, trans, say it negative. Plus into plus or minus into minus is positive. Therefore, if we are adding a group AB across the double bond, then in Fischer projection, then AB will fall on same side. And in other case, plus into minus or minus into plus is minus. Therefore, the groups AB will be in this way on Fischer projection. Now, when bromine comes near to alkene in carbon tetrachloride, polarization occurs. The double bond attracts one of the bromine atoms, thereby loss of Br minus ion, that produces cyclic halonium ion. Now the cyclic halonium ion is attacked by Br minus, and it can either attack on this carbon and thereby ring opens in this direction, or it may attack this carbon and ring may open in this direction. As I said, this is trans isomer, addition is anti, the expected product is Br and Br on the same side, pH and pH, H and H. Let us confirm that. So this is going to be the Sahar's projection of the product after bromide attack. Now let us rotate this carbon and as well as this carbon to have this projection which corresponds to this particular Fischer projection. Now that is a product. Now for this product we have to make conformations, and of course directly we make conformers. For this Fischer projection, which is a meso compound, this is Sahar's projection, and I am placing both pH groups on eclipsing position. The corresponding Fischer Newman projection is this. Here dihedral angle I put as 0. Now for this Newman projection, let us construct conformer. Please note that conformers occupy local minima in energy surface diagram. Now that is one conformer, and by rotating 120 we get this conformer, and then rotating further we get this conformer. And among these conformers, now see the potential energy local minima, they are occupying local minima in potential energy diagram, and see how their dipole moments are. In this conformation, the dipole moment vector in this direction, and here it is in this direction, here in this direction. The net dipole moment is not equal to 0. And in next conformer, the dipole moment vector here in this direction, for CBr, and these are the directions, net dipole moment is equal to 0. And in third conformer, we have the phenyl groups in this direction, which has net dipole moment, and Brs in this direction and net dipole moment is again not equal to 0. Therefore, for a given reaction product, out of 3 conformers, 2 conformers have non-zero dipole moment.